Hi, everyone. In the previous session, we explained and we gave the congruency tests. There are 4 of them, and each one needs some conditions to be verified to verify that we are talking about 2 congruent triangles. What we mean by congruent triangles are the congruent triangle are equal in shape and size. So normally all the sides, each pair of matching side are equal, and also each matching or corresponding angles are equal. Good. So today we want to explain how to use and to use these tests and to use the resulting the consequence of having a congruent triangle. So let's move. First of all, we have this example. They ask us that to complete, for example, the following to prove that the triangle ACD is congruent to ACB. We have A, C, B, A, D, C. Congruent, we have 4 different tests. So we should use one of these one. The first one is about sides. If all the sides are equal, so normally we are talking about congruent triangles. Normally we hear this mark, this sign is for congruency. Okay, so normally we can remark clearly that we have 3 pairs of equal matching sides. Why? Because we have this mark here equal to this one, identical to this one, so AB equal to AD from the other triangle. And also with the same reasoning, we say that BC equal to DC, and we have the third side is a common side. It's common side between the 2 triangles. So normally, yes, AC equal to AC, of course. So normally, these 2 triangles are congruent by S, 3 sides, 3 pairs of equal matching sides. So what are the results of having congruent triangles? All the remaining angles, all the remaining non-used in the for example in the justification of congruency, not used, the sides not used, the non-used sides, and also the angles which are not used, and the justification are all equal. So, but we should take care of finding the corresponding matching angles. What we mean by that? When we used here the SSS test as a congruency test, so normally it remains 3 angles. So we should indicate which angle from the first triangle equal to the matching, which the match angle in the second triangle. So normally it is easy because what is the opposite of this side? It is this angle. Normally we find the same side in the other triangle, and we find the opposite angle to it, this one. So normally these 2 angles are equal. So we can say that BCA equal to ACD. In the same way, we can analyze the same thing because we have this side here equal to this side here. The opposite of this side is this angle, and the opposite of this side and this angle in the other triangle. So normally this angle equal to this angle. So we can say that BAC equal to CAD, and the 2 remaining angles are equal. The 2 remaining angles are clearly B and D. So these are the matching angles from the 2 congruent triangle. And you know, this one is the symbol of congruency, and we can read it as congruent too. So normally, in the second exercise, we apply the same strategy to find out the results, the consequence of having congruency. And and also to test and to verify and to use the appropriate test of congruency for the both triangles. Easy, because you should base your justification on the given. Like here, for example, I have a one side and one side are equal. Good. We have an angle and the angle. Normally, we don't have any other pair of sides, matching sides equal. So normally we search for angle because we have a AAS test. So normally we need an angle. What we have here, clearly we have opposite vertical angles here because we have a vertex P intersection where BD and AC as straight lines intersect. So normally we have an opposite vertical angle here. So yes, this angle equal to this angle. So we can say that these two triangles are congruent by AAS. Okay, and the same here for the test, we use two angles. It remain one angle. So the remaining angle, for example, this one and this one for sure are equal because it is a natural result of having congruent triangles. Okay, and when we used one side, so the two other sides also equal. Which one? We have this angle, so the opposite of this one is this side, and this angle is equal, a match to the matching of the other, so the opposite side is equal. So normally BA equal to CD. Okay, and so on and so on. So easy. Okay, easy. In the same way, I noticed here I indicated here the hint how to which test to use in each case of these triangles, and we should know, for example, because we are talking about analyzing in geometrical we use geometric analysis. So we need to know the properties of some particular triangle, like the isosceles triangle. We should know an isosceles triangle have two sides, two adjacent, or we can say two consecutive sides are equal. And one of the main property of a triangle, isosceles triangle, the two angles opposite to the equal sides are equal. We have this side, so this angle, this side, the opposite to this angle, so these two angles are equal. And we should know that the altitude, we say the altitude. Normally, when we have an isosceles triangle, we say that we have a main vertex. The main vertex here is A, because from A we have the two equal sides. Okay, the altitude only. The only altitude coming from A, altitude, the perpendicular, issued from A to the opposite side, to its opposite side, okay, altitude perpendicular. Normally, it is in the same time, it is congruent to altitude, the perpendicular is congruent to the angle bisector. What we mean by the angle bisector? So normally this altitude cut the angle A into two equal angles. It is a like bisector. So the altitude at the same time is the bisector, and in the same time is a median. What we mean by median? Cut the side into two equal parts, portions. Okay, so we should take care of these properties because they are true and very useful, okay, in the analysis that we need to know. For example, here P, Q, and S is an isosceles triangle with PS equal to PQ. Yes, we can verify that that we have an isosceles triangle if we verify that we have two equal sides or two equal angles. So normally here they use two equal sides, PS equal to PQ, so it is an isosceles triangle. When we have an isosceles triangle, so we have the other property as a result. What is the other property of a of an isosceles triangle, the angles of the base are equal. So normally we have a S equal to Q. It is a result. It is like a given, but hidden given. Okay, and PR perpendicular to SQ. PR perpendicular to SQ. It is the altitude. We should keep in mind that's the altitude issued from the main vertex, the vertex having the two sides equal. Okay, the altitude is the median. So median, so this side equal to this side, this part, and in the same time the bisector. So normally this one equal to this one. Yes, good. Let's move. Prove that the triangle PRS, PRS, and PRQ are congruent because we have the symbol of congruency here. So normally we don't have three sides. Yes, we have three sides if we use properly our mind, because this one equal to this one, and this part equal to this part, because the altitude issued from the main vertex, principal vertex in an isosceles triangle is a median. So it's cut the side, the base, SQ into two equal parts. So normally this one equal to this one, and we have the third sides, and we have the third sides as common side. So normally by SSS, or we can use by AAS. AAS. Good. Normally, when we have all this information, we have two triangles are congruent. PSR, so PSR and the PQR. So the angle PSR. So PSR and PQR, yes, are equal. We know that these two angles are equal. Why these two angles are equal? Because we are in right triangle. We are in isosceles triangle. So the angles and the base are equal. The base are equal. SR equal to QR. SR equal to QR. As I said before, the altitude it is the same time bisector median. Good. And SPR, yes, to the bisector, so are equal. Oh, good. It is a good one. Also we can continue to have complete the following two properties. The angle opposite the equal sides of an isosceles are equal. Yes, so it is like a property, you can memorize it. So all the results here you can memorize it ahead, okay, before starting analyzing or giving the results. So it is very important to assess yourself by the following exercises. For example, here we have a parallelogram. The parallelogram is a quadrilateral, okay, with each pair of opposite sides are equal in size and equal and parallel. So parallel, equal, parallel, and equal. When we have a parallelism, so and intersection, we have intersection inside. So normally we can use it to form the Z. When we have Z alternate angles, so this one equal to this one, or we have Z in the other sides. We have a Z in this way. So this angle equal to this angle. And when we have an opposite vertical angle, so this angle equal to this angle. Normally, using the three angles are equal, we have three angles from this side equal to three angles in this side and of this triangle aren't enough to verify that these two triangles are congruent. We can say that these two triangles are in the same shape, but not necessarily in the same size to be congruent. But we know that the diagonals in a parallelogram intersect in their midpoint. So what we say here, that midpoint, so T is the midpoint of PR, and T in the same time is the midpoint as SQ. So we can say that this part equal to this part, and also this part equal to this part. Okay. So normally, when we have all this, we have so PS equal to QR, and we have a PT equal to TR equal ST equal to TQ. So by SSS, this triangle is congruent to this triangle, and with the same reasoning, we can say that this triangle is congruent to this triangle. So these are the main idea of our lecture of today. Thank you for listening, and bye bye. Have a nice day.